here's a definition here. Well, we've sort of done it before. Remember what's a language? Forget what I was saying a couple of sessions back. It was embarrassing. A language, not an alphabet. A language is a set of strings. Okay, it's as simple as that. So the strings, the strings that are accepted by this machine, call those strings W. So the set of W are those strings that are accepted by this machine. So all the strings that are accepted by this machine, put them in a set, call that set a language. Okay? And that language, call it A, that's the language that is recognized by machine M. Okay? So you can say that machine M, the automaton, recognizes language A if this, the definition of what a language is. It's a set of strings that are accept all strings, all of them, a set of strings that of all strings that the machine automaton M accepts. Okay, right. Now a new definition. Now remember, if you go back a few sessions, can you remember the very title of this whole chapter? It was regular languages. Okay, so now soon. Now we have enough information to define what a regular language is. Okay? And here it is. Here's the definition. So definition in your text 1.16. A language is called a regular language. Regular, sort of in the sense of normal, garden variety, not special, sort of usual, regular. Here's your regular guy. You're just an ordinary, average sort of guy. Right? So this is just an ordinary, average sort of regular language. Okay? So what's a regular language? Well, a language is said to be regular if there is, the mathematical symbol, there is an automaton that recognizes it. Okay? So reword that, sort of make it. So if there's some machine, some automaton, M, that recognizes that language is said to be regular. That's all it is. Okay? You need to memorize that. So now we understand what the title of this chapter, the first chapter, is about. Right? We've been talking about regular languages. In other words, there's some machine, some automaton that recognizes it. Okay. All right. Okay, now an example, so this is example 1.17. It's an example of a regular language. It's not surprising. They've all been regular languages so far, because they've all been, we've been talking about languages that have been recognized by automata. So I guess the textbook writer, Sipser, does not state this at the moment. But I suppose you might be asking, well, if he's talking about languages that are recognized by some automaton, does that imply that there are other kinds of languages, other languages, that are not recognized by an automaton? And I'll just leave you with that question. I won't answer it. Okay. Now, here's another example. So example 1.17 in the text. Here is your state diagram, your state transition diagram. What is it? It's in fact example 1.13. So that is again your summer, the running sum mod 3. So we're use it since then twice. This is now the second time, right? But and what is all this? Well, we're giving now the formal definition of the computation, of that computation. Like, for example, here here's the sequence of states that the machine goes through, and I've put this diagram here. In fact, this is not in the text in this example. I've put this here because without it, it's sort of hard to understand what's going on. That's one of the disadvantages of me using, you know, one session about this wide, so you cannot see the the state diagram from an earlier session. And okay, so I've drawn it here again so you can figure out what's going on. Okay, so so we're talking machine M5 again, which was example 1.13 from the text. Now let the string, now remember the alphabet of the string had 4 symbols, different symbols, 0, 1, 2 and reset. Okay, so here's the string that goes into this automaton, which I've reproduced. It's just the same as how many sessions back? 2? Yeah. Yeah, two sessions back. So I've just reproduced it again. Okay, so this is the input string. So 1, 0, reset, 2, 2, reset, 0, 1, 2. And okay, let's find the sequence of states that it goes through. Now, I'm going to use my I'll use the felt tip pen, and I'll use just an ordinary ballpoint pen. Right? So left and right. So follow me as I go through. Okay. Now where's the start state? Well, here's your arrow. Right. So we start in state Q0. So your first state, your Q0, is here. Right. Now I need 3, don't I? I need 3 hands. I'll just say this verbally. Right. I can't point to it. I've only got 2 hands. So I'll just say this verbally, and I'll go through the diagram and the sequence, the state sequence, step by step, and I hope you follow it. Right? Okay, start state Q0. My left hand is indicating the current state, right? And my right hand is indicating the state, the corresponding current state in the sequence of states. Time's going this way, right? Start state Q0. And then a 1 comes in, so we move to here. And here's a 1. Okay, so we're in Q1. And then a 0 comes in. Here. Let's see, I've got to remember what it was. Okay. And then a 0 comes in, so we're back into Q1 again, so we're here. And then a reset. So back into Q0. Yeah, reset takes you back to Q0, so we're here. And then a 2 goes to here. So now we're in Q2. Okay? And then another 2. So now we're up in Q1. And a reset, so Q0 again. And then 0, back to Q0. And then a 1, so Q1. And then a 2, okay, Q0. And that's it. The string has run out. And we're in Q0, and that is an accept state. There's only 1. Okay? And therefore, this string is accepted by this automaton, by M5. Okay? So, did you follow that? Using the... Well, I was using state diagrams. It's sort of easier. You could use the formal definition with the transition functions. All those deltas of here. You could do this, but it's just easier, especially if automaton is simple, just a small number of states. Okay, so we went through the sequence. For this string, the final state was an accept state, and therefore this string is accepted. Alright, now what is the language? The set of all input strings that are accepted by this automaton, that set defined to be the language recognized by this machine, by this automaton. Okay, now what is that language? Let's do a description of it. Well, it'll be the set of all strings W such that, well, you know, it's this example, right? So it's the set of W, and where the, you know, such that the sum of the symbols, you know, 0, 1, 2, in W is 0 mod 3. Okay? Except that, you know, resets the count to 0. Okay, now M5, that's this automaton. It recognizes this language, you know, W. This is just short for all this, you know, from here to here, and all that description. Just a shorthand of that. Okay, so that's the language, and it's a regular language. Right? Why? Because that language is recognized by an automaton. Which one? Well, M5. Right? So this language, this W, you know, set of W, you know, this language L, described, you know, by this, that language is recognized by an automaton. Which one? M5. Therefore, this language L, you know, this language, you know, the set of all the strings W, that language does have an automaton that recognizes it. Therefore, that language is a regular language. Okay?